Okay, so in this lesson, we're going to graph quadratic functions that are written in standard form. Now remember, standard form is sometimes called, some textbooks will call it vertex form. And the reason it's called standard form or vertex form is because when it looks like this, you could easily determine the vertex. So that was from previous lessons. Remember, the vertex would be HK. Now, when we talked about this in the previous lesson, just remember it's got to be x minus, and then you got to rewrite it as x minus, and then that number that appears after the subtraction symbol, that is your h. Okay, now a couple of things when graphing the quadratic functions that are written in standard form. So we're going to do standard form first. It does help if you first determine whether a is positive or negative. So remember, if a is positive, and remember that's going to be in your resources. So if a is positive, the parabola opens up. If a is negative, the parabola opens down. Then the next thing you want to do is determine the vertex. So step 2 is determine the vertex. Step 3 is to find any x-intercepts. So there may or may not be any. All right, and then the function's real zeros are the x-intercepts. So to find the x-intercepts, you would set the function equal to 0. All right, because remember, the x-intercept is where y equals 0, so make sure you understand why we say f of x equals 0, because f of x is the same thing as y, and wherever the graph crosses the x-axis, the y coordinate is 0. So all you do is just set the function equals 0 and solve for x. The y-intercept, there's always going to be a y-intercept. When you're graphing quadratic functions, there will always be a y-intercept. So that's why you don't see the word if any. All right, and to find the y-intercept, you let x equal 0. So that's what this is. So find y when x is 0. Then you want to plot those intercepts. You want to plot the vertex and any additional points as necessary, and then you connect the points. Okay. Now, one of the things that they're going to ask you to do in this lesson is also determine what the domain and range is, and then the axis of symmetry. So all that's going to be in here when we discuss this. Okay, so let's look at number 1. Let's go ahead and graph. Remember, we're graphing each of these, and each of these can be written in standard form. So the first one will be f of x equal x minus 3 squared minus 4. Okay, so x minus 3 squared minus 4. So the first thing you want to do is determine, does the graph open up or down? All right, well, since a, remember a is the number right here, since a is 1, that's positive, so since a, which equals 1, and that's greater than 0, let me just rewrite it, which is positive, the parabola opens up. Okay? Then we find the vertex. So the first thing, letter A, is to determine whether it opens up or down. So since A is positive, A is 1, that's positive, it opens up. The vertex, okay, find a vertex next. So the vertex, remember, is the x and y coordinate. So h in this case is, remember, x minus h. So h is 3, and k is negative 4. So that's your vertex. All right, then you want to determine the y-intercept. Let's do the y-intercept. The y-intercept is always the easiest. To find the y-intercept, remember, you let x equal 0. So when let x equals 0, I'm going to get f of x is y. So I'm going to get y equals, in parentheses, x, which we're saying is 0, minus 3 squared minus 4. So that's a negative 3 squared minus 4. And negative 3 squared is 9. 9 minus 4 is 5. So my y-intercept, the y-intercept, as an ordered pair, is 0, 5. Okay, the x-intercept. Before you even do anything, before you even set the function equal to 0 to find the x-intercept, determine if there are any. Okay, so are there any x-intercepts? Are there any x-intercepts? And it's easy to determine that. First of all, locate the vertex. So the vertex is 3, negative 4. So 3, negative 4 is in the 4th quadrant. The parabola opens up. So that's that. So yes, you will have x-intercepts. So the answer, are there any x-intercepts? The answer is yes. okay, from here. All right, so what we did, we quickly determined where the vertex was. The vertex is in the fourth quadrant. The parabola opens up because A is positive, so it's 1, so that's positive. And so it will cross the x-axis. So now we can find it. So now find the x-intercepts. So find the x-intercepts. All right, so remember to find the x-intercepts, you can let y equal 0. And remember, y is the same thing as f of x, so this is going to be 0. So we're going to get this function here. So we get x minus 3 squared minus 4, and that has to equal 0. So all I'm doing is setting this equal to 0. All right, now remember in the previous lesson, you had to solve an equation using a square root property. Remember that? So when using the square root property, you have that binomial squared. So also you had to get that binomial squared by itself. So what you had to do next was add 4 to both sides. And so I add 4 to both sides. I get x minus 3 squared equals 4. And then remember, the next thing you did was take the square root of both sides. So I take the square root of both sides, I got plus or minus. And so the square and the square root into each other. So I get x minus 3 equals plus or minus 2. Okay? And then since this is a rational number, you wrote this as two separate solutions, two rational solutions. So I get x minus 3 equals 2. X minus 3 equals a negative 2. And so when I add 3 to both sides, I get x to be 5. When I add 3 to both sides, I get x to be 1. So my x-intercepts are 5, 0. These are x-intercepts. There are 2 of them. The x-intercepts are 5, 0 and 1, 0. All right, then they're going to want you to sketch that graph, and then the other thing they're going to want you to do is determine the axis of symmetry. Well, remember, based on the previous lesson, once you know the vertex, you know the axis of symmetry. So E, the axis of symmetry, it's an equation, so it's x equal. Remember, the axis of symmetry is a vertical line. So it'll be x equal, and it's always that x coordinate of your vertex. So the x coordinate of your vertex is 3. So axis of symmetry is x equal 3. Don't just put 3. You have to say x equal 3 because it is a line. In this case, it's a vertical line. So you got to say x equal 3. Don't say 3. You have to say x equal 3. You have to state the equation of that line. All right, and then let's go ahead and graph. And then from that graph, we're going to determine the domain and range. All right, so domain and range. So the domain will be this, and the range will be this. Okay, so let's graph this. So we're going to graph the vertex. So we graph the vertex. So the vertex is 3, negative 4. So 3, negative 4. So 3, negative 4 is here. Okay, and then we know the y-intercept is 5. The y-intercept is 5, so that's way up here. We know that the x-intercepts are 5 and 1. So 5 and 1. And that's all they want you to do. So all they want you to do is to graph this quadratic function using intercepts, the vertex, the y-intercept, and any additional points as necessary. You're going to see what we mean by that. Okay, now if I graph, if I draw the axis of symmetry, so I'm going to use the axis of symmetry to help me to draw a graph of this quadratic function. So remember, the axis of symmetry goes through the vertex. So I'll draw the axis of symmetry, something like this. Make sure it's a dotted line. Make sure it's a dotted line. Draw your arrow. All right, and then remember, always double check. See how the x-intercept is 2 units from the axis of symmetry. Make sure this is 2 units as well. So 1, 2, it is. And then any additional points, here's where the additional points come in. This is 3 units from the axis of symmetry. Go 3 units this way. 1, 2, 3, and then draw your other point. Plot your other point. And so there you go. There's your graph. Just do your best you can with graphing this. Make sure it's a curve. Make sure it's a curve, and it kind of does this. Okay? Same thing here. Make sure it's a curve, and it kind of does this. All right, so that was number 1. So number 1 was f of x equal x minus 3 squared minus 4. Okay, number 2. So let's look at number 2. Oh, by the way, I forgot to do the domain and range. All right, so domain and range. Okay, so what I want you to notice is that when we go through every quadratic function, remember the parabola is going to either open up or it's going to open down, okay? But regardless of whether it opens up and opens down, I want you to notice the domain. So regardless of whether it's going this way or whether it's going this way, down, the domain, remember your arrow keeps on going, so the domain is going to be from negative infinity to infinity each time. So for your domain, for any quadratic function, the domain is all real numbers. So you can say negative infinity to infinity. Now the range, it depends on whether it's a max or a min. So I'm going to ask you this for letter H. Is the vertex a maximum point or a minimum point? Maximum or minimum point? Right? So in this case, you know that it's a minimum, it's a low point. So decreasing, increasing. So it's a low point. So it's a minimum. So the answer, minimum. All right. And if they ask you what's that minimum value, you're going to say, what is that minimum value? What is the minimum value? Now, when they say the minimum value, they're talking about the y value. All right, so the y value. So the question then becomes, what is this lowest y value? Well, the lowest y value is negative 4. So the answer, negative 4. Okay. Now the range, remember the range, you go from bottom up along the y-axis. So I start touching my graph when I'm at y equal negative 4. All the way to, and notice the arrows keep going, so that's infinity. So your range is going to be from bracket because that negative 4 is part of your graph. Negative 4 all the way to infinity. All right. Okay. Let's look at number 2. So number 2, same directions, except this time we're going to look at this function, f of x equal x minus 2 squared minus 2. So x minus 2 squared minus 2. Let's see. Okay, so first thing we do is letter A, let's say. Does f of x open up or down? Does f of x open up or down? That's a question. Well, since a is positive, remember that's a right here, the number in front of the binomial. Since a is a positive 1, the graph opens up. Since a equals 1, which is positive, the graph opens up. Okay, B, we'll find the vertex. So the vertex, remember it's x minus, so it's the vertex, so the x-coordinate vertex will be a 2, and the y-coordinate is negative 2. So there's your vertex. C, let me make sure I use the same order as in the first problem. So C, you want to find the y-intercept. Okay, so the y-intercept, you're going to let x equal 0. So when I let x equals 0, I get y equals, in parentheses, x, remember, is 0. So 0 minus 2 squared, minus 2. So 0 minus 2 is a negative 2. When I square a negative 2, I get a positive 4. 4 minus 2 is 2. So what I found was the y-intercept. So the y-intercept is going to be the ordered pair 0, 2. Okay? Now let's find the x-intercept if any. So D, x-intercept, so find x-intercepts if any. First of all, let's determine if there are any. Okay, so my vertex is 2, -2. It's in the fourth quadrant. My parabola opens up. So notice I am going to get x-intercepts. All right. So find the x-intercepts. So I will get x-intercepts. All right. Find the x-intercepts. You let f of x equal 0. You let y equal 0. So basically, this function on your right is going to have to equal 0. So what I'm saying is that x minus 2 squared minus 2 must equal 0. And then notice it's in that vertex form. So at some point, you're going to take the square root of both sides. So remember, before you take the square root of both sides, you got to get that binomial squared by itself. And it's not by itself. So you have to add 2 to both sides first. So I'm going to add 2 to both sides and combine my terms. I get x minus 2 squared equals a positive 2. Okay? Then we can take the square root of both sides. So when I take the square root of both sides, x minus 2 squared equals 2. So when I take the square root of both sides, don't forget the plus or minus here. I get the square and the square root into each other, so I get x minus 2 equals plus or minus the square root of 2. Okay? Now, here's what I would do at this point. So you're graphing this. Okay? Now, in a previous lesson, you would leave it as square root of 2 and then just add 2 to both sides. But here we're graphing. Since we have to plot the x-intercepts, all right, since we have to plot the x-intercepts, round to the nearest tenth. Okay, so round to the nearest tenth. So basically, you're going to do this. You're going to say x minus 2 equals the square root of 2. X minus 2 equals negative square root of 2. And so I'm going to get x equal, remember we add 2 to both sides, so you get 2 plus the square root of 2. And then on your calculator, approximate this. So 2 plus the square root of 2. I'm going to have to use a calculator that I don't normally use. So, alright, so we're going to say, make sure you put this in your calculator, see if you get the same thing. Now, this is not the calculator that you normally use. So you get 2 plus, and then the square root. Oops. Alright, so 2 plus the square root of 2 is 3.4. So that's approximately 3.4. Over here, we're going to add 2 to both sides, and then use a calculator to approximate the x-intercepts. I get 2 minus, I really should have used my calculator, 2 minus the square root of 2. Okay, and then 2 minus that. Looks like we get 0.6, 0.6. Alright, so my x-intercepts are it's going to cross the x-axis at 3.4, and the other one is going to be 0.6. So as ordered pairs, you get 3.4 comma 0, and then 0.6 comma 0. Okay. All right. Now the next thing you want to do. All right. That was the x-intercept. Okay. So then you want to find the axis symmetry. Okay. Axis symmetry. All right. So remember, the axis symmetry is a vertical line. So you can say x equal, and then it's just the x coordinate of your vertex. So the x coordinate is 2. So the axis symmetry is x equal 2. All right, and then the next thing you're going to do is you're going to graph. We're about to graph this. And then the next thing, once you graph it, you're going to ask yourself, oops, I forgot to do the domain and range. E, F, G. So domain and range. Okay. And then once we find the domain and range, we're going to ask ourselves, is the vertex a minimum or a maximum point? Okay. And And we're going to ask what is, what is the minimum maximum value. Okay. All right. So let's start graphing this. All right. Just think about what we did earlier. So you're going to do this first. You're going to plot the vertex. So the vertex is find the page. Looks like the vertex is 2, -2. So 2, -2 is here, right here. 2, -2. And then it looks like the y-intercept is 2. The graph crosses the y-axis here. It looks like the x-intercepts are approximately 3.4. So here's 3, here's 4. So 3.4, let's say, is here. And the other x-intercept is 0.6. So let's say that's about here. I do the best you can with estimating. And then let's draw the axis symmetry. So I draw the axis symmetry. Remember, your problems have to be symmetric about that line, the axis symmetry. Right, draw your arrow. And then let's just do this additional point right here. So this is 2 units. This has to be 2 units. So there's the other point. And then you just draw your graph. It's kind of like this. Okay? Right, and then from there, let's just quickly determine the domain and range. Now remember, this is a quadratic function. So your arrows, make sure you draw your arrows. Your arrows are going up, and so in terms of my domain, I'm going from negative infinity all the way to positive infinity. So always, whether your graph goes up or down, the domain will always be all real numbers. So you can say negative infinity to infinity. Okay? The domain is going to be negative infinity to infinity. The range, remember, you go from along the y-axis, so you're going to go bottom up. So for the range, I start touching the graph when x is -2. So I go from -2 all the way to infinity. As you have to say, -2 to infinity. Bracket -2, comma, infinity. And then in this case, you see how the vertex was a low point? So that's a minimum. So is the vertex a min or max? You can say answer will be a min. All right, and then what is the maximum, what is that minimum value? So the minimum value is, so the minimum value of the vertex, remember that's the y-coordinate they're asking for. So don't say 2, the y-coordinate is a -2. So the minimum value is -2. All right, now, so that's number 2. Okay, number 3. Okay, number 3, suppose you had y equals 2 times x minus 1 squared plus 3. So 2 times 1x minus 1 squared plus 3. Okay, so letter A, does the function, does y open up or down? Okay. Since a equals 2, which is positive, the function opens up. Okay, function opens up. Okay, now part B. Let's find the vertex. Remember, this is in standard form, this is vertex form. So x minus h. So h here is 3, and y is just a constant. So a constant is a positive 3. So the vertex is 1, 3. Okay, now, part C, you want to find the y-intercept. So there's always going to be a y-intercept. So find the y-intercept. Every function is going to have a y-intercept. So when I find the y-intercept, remember you got to let x equal 0. So unless let x equal 0, I get y equals 2 times x is 0, minus 1 squared plus 3. and then I just use some algebra or some order of operations to figure out what all this equals to. So according to order of operations, let's put into parentheses first. 0 minus 1 is a negative 1. Squaring that, I'm going to add 3. Negative 1 squared is 1. 1 times 2 is 2, so that's 2. 2 plus 3 is 5. So the x-coordinate of your vertex, I'm sorry, the y-coordinate of your, the y-intercept is going to be 5, 0, 5. 0, 5. That's the y-intercept. So that's why the graph's going to cross the y-axis. Okay, now let's find the x-intercepts. So find the x-intercepts if any. So remember, you may or may not have any. Okay, now don't do all that work if you don't have any. If any. So basically, you're going to look at the vertex. The vertex is 1, 3. So that's in the first quadrant. And then you're going to ask yourself, does this graph open up or down? It turns out the graph opens up. So there is no x-intercept. The graph doesn't cross the x-axis. So according to this, there is no x-intercepts. There are no x-intercepts. Okay? All right, so there are no x-intercepts. Okay, E. So part E, the axis symmetry. So part E is the axis symmetry. All right, so the vertex is 1, 3. So the axis symmetry, remember, is x equal the x-coordinate of your vertex. So the x-coordinate of the vertex is 1. So x equal 1 is your axis symmetry. All right, so then F, you're going to graph. And then G, you want to find the domain and range. And then H, you want to determine is the vertex a max or min. Okay. And so then once you've determined if the vertex is a max or min, you want to find that minimum or maximum value. Okay? So all this is right here. You haven't seen it. So you can graph and you can find the domain and range, and then you're going to ask yourself, is the vertex a max or min? And then you're going to find the vertex. Okay, so let's go ahead and graph this. Now, even before you graph it, I hope you realize that you can determine the domain and range, and then you can determine whether the vertex is a max or a min. So see right here, the parabola opens up, so that's going to be a min. So that's a min. So answer, vertex is a min. Okay, and then you want to find that minimum value. So the question is, what is that y value right here? Well, the y value is 5. Okay, so remember this is, 1, 3. This is 1, 3. Your vertex is 1, 3. So that minimum y value is 3. So the answer is 3. Okay, and the domain and range, remember the domain and range. The domain and range, you're going to use a rough sketch to determine that. I mean, you can, or you can use the graph you're going to draw. But just remember, the domain for all quadratic functions, you have arrows pointing up, or they could be pointing down. But the domain is going to be from negative infinity to infinity. It's all real numbers. So negative infinity to infinity. Now, the range is not all real numbers. Okay, so when I go along the y-axis, start touching the graph when y is 1. So I go from 1 to infinity. So the range will be bracket 1 to infinity. Okay, let's start graphing this. So this is number 3. Number 3. So when I graph number 3, alright, so when I graph number 3, I'm going to plot the vertex. So that's 1, 3, right here. The parabola opens up. Alright, so that you know there aren't any x-intercepts. It crosses the y-axis at 5, and that's all we know. Alright, so I'm going to go ahead and draw the axis symmetry. For the axis symmetry. So when I do that, draw a dotted line, I get something that looks like this. Okay? Alright, now, you remember you had to determine the vertex, you had to determine the intercepts, x and y. There are no x-intercepts. There's only one y-intercept. Remember, all functions have just one y-intercept. And use any additional points if needed. So basically all you're going to do is, see this point right here? That's 1 unit from the axis symmetry. Go 1 unit this way. And you have enough points. Just do the best you can with drawing this. And remember, it's not a V. So don't make that mistake. Okay, it's got to look like a parabola. It's got to look like a parabola. Do the best you can with making it look symmetric. It's not. I did a bad job with this. So it should have done this. Okay, let me go ahead and redo this. All right, so let's do this over. So 1, 3. You have the y-intercept here. Your axis symmetry is here. There are no x-intercepts. You know from the fact that the y-intercept is 1 unit from the axis symmetry, I can go 1 unit this way and plot another point. Okay. Now, 3 points really is not going to help you to graph this because you really need to make this symmetric. So what I would do is I would just pick, see how you have x equal 2 here, then do x equal 3. So I would just, let's see, the function was this. Y equals 2 times x minus 1 squared plus 3. So let x equal 3 and find out what y is. So that will give you 1 more point. So when x is 3, I get 2 times 3 minus 1 squared plus 3. Oops. Plus 3. And then 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. So I get 8 plus 3, which is 11. Okay, so I get 311. So 311 is way up here. And so I go 1 unit. We see how this is 2 units in the axis symmetry. I go 2 units to the other side. So 1, 2. So I plot this point. Right, and then I'm just again with drawing this like this. And now it kind of looks a little bit better. It could be a little bit better, but it's better than the previous one. So we don't have any x-intercepts. Then just go ahead and determine another x value for x, and then find out what y is, and then plot the point and draw your graph. Okay, so let's do one more with this. This is number 4. Number 4. Now, I just want to mention this before we go on. Suppose you did not realize, and this is important. Suppose you did not realize. See right here, because some of you are going to do this, and that's fine. Suppose you did not realize that based on the rough sketch there were no x-intercepts. Okay, so remember in number 1 or number 2 rather, to find the x-intercepts, you would set f of x equals 0. So you would set this whole thing equal to 0. So when I found it here, it was here, and I brought the 2 over and I took the square root of both sides, I got x minus 2 equals plus or minus square root of 2. And then I went from there. But in this case, I want you to notice something. If for some reason you did not do this part, or you're not sure how to do this part, which you should be sure. But let's say you're not, and you set this equal to 0, you set f of x equal to 0, here's what you would get. So you need to understand this. So find the x-intercepts. Okay, other approach. So when I find the x-intercept, I'm going to get 2 times x minus 1 squared plus 3 equals 0. So that's what I get. All right, now remember, we got to get the square part by itself. At some point, you have to take the square root of both sides. So I'm going to subtract 3 from both sides. So I get 2 times x minus 1 squared equals negative 3. Then divide both sides by 2. I get x minus 1 squared equals a negative 3 halves. Okay, that's a negative 3 halves. All right, now I want you to notice something. When I take the square root of both sides, at this point, when I take the square root of both sides, and do the plus or minus, and the square and square root of each other, get x minus 1 equals plus or minus the square root of negative 1.5. Remember, 3 halves is negative 1.5. I cannot take the square root of a negative number, so that's not a real number. It's not a real number. So remember, we're graphing points. This right here is an imaginary number. It's a complex number. So I can't go any further. It's not a real number. So what that means is that there are no x-intercepts. So this means there are no x-intercepts. Okay? All right. Just wanted you to be aware of that. Okay, number 4. Let's suppose we had y equals x minus 1 squared minus 3. All right, so y equals x minus 1 squared minus 3. Let's make it f of x. Let's use function notation. All right, so does the function open up or down? Well, since a is 1, which is positive, f of x opens up. Since a equals 1, which is positive. Okay, all right, take a letter B. So in letter B, you want to find the vertex. So the vertex, so this is in standard form, so vertex form. So x minus h, so the vertex is 1 comma negative 3. That's your vertex. Let's find the y-intercept. Y-intercept. So to find the y-intercept, you're going to let x equal 0. So when x is 0, I get 0 minus 1 squared minus 3. 0 minus 1 is a negative 1. I got to square that, then I subtract 3. That's 1. 1 subtract 3 is a negative 2. So my y-intercept is 0, negative 2. That's your y-intercept. Okay, then D, you want to find the x-intercept, if any. All right, well, think about it. Is there a x-intercept? Well, in your mind, you know that the vertex is 1, negative 3. So that's here. That's assuming that this information is correct, because you could have messed up there and then gotten the x-intercept incorrect. So you gotta think about what you have and whether it's correct or not. So when I plot the point 1, negative 3, and I know that the parabola opens up, I am going to get 2 x-intercepts. Okay? All right. Then so we found the x-intercept. Now let's find the axis of symmetry. Oops, we didn't find the x-intercept. I'm sorry. We've got to find the x-intercept. All right, to find the x-intercept, we're going to set this equal to 0. It's x minus 1 squared minus 3 equals 0. And then I'm going to add 3 to both sides. So I get x minus 1 squared equals 3. And then we take the square root of both sides. So it's in that form where you can eventually take the square root. So I'm going to take the square root of both sides. Let me go ahead and rewrite this over. So square root of both sides. Don't get the plus or minus. And the square and the square root undo each other. So we get x minus 1 equals plus or minus the square root of 3. All right, so we can get a real number. That's not an imaginary number because I'm not taking the square root of a negative number. But what I'm going to do is I'm going to split this in 2 parts because I am going to approximate this. All right, so I approximate this and get x equal 1, add 1 to both sides, plus the square root of 3, and this is 1 minus the square root of 3. Now use your calculator. What is x approximately equal to? So if you're doing this correctly, one of your x-intercepts better be, and again, I'm using a calculator that you don't use, so it's going to, don't look at the order which I do stuff here. So 3 square root plus 1, plus 1 equals 2.7. So that's about 2.7. over here. 3 square root minus 1. So here I'm going to get negative 0.73, 0.73. Okay. Verify this again. Okay. All right, and then so those are your x-intercepts. Okay, so 1 plus square root 3, 1 minus square root 3. So use your calculator. That'd be 2.7, and then 0.7. Just round to the nearest tenth. 0.7. Okay. Now, the next thing we had to find was the axis of symmetry. So the axis of symmetry. So the axis of symmetry. The axis of symmetry. You're gonna look at your vertex. So the vertex is what's this number 4? The vertex is 1, negative 3. So the axis of symmetry, x equal the x coordinate of the vertex will be 1. So that's your axis of symmetry, x equal 1. Okay, then we're going to graph. And then once we graph, we're going to determine the domain and range. And you can determine the domain and range now if you want to. All right, and then you're going to determine, in letter H, you're going to determine if g of x has a max or min. Okay, and then you're going to determine what is the max or min value. Okay, so let's graph this. So when I graph this, I'm going to graph the vertex. So the vertex is 1, negative 3. That's about here. That's your vertex right here. And then I know that the y-intercept, 1, negative 3. Okay, so then I know the y-intercept is negative 2. That's here. And then I know that the x-intercepts are 2.7, 0.7 rather, 2.7, 0.7. And those are approximations. So 2.7, let's say it's about here. And then negative 0.7 is, let's say, here. All right, and then that should be enough points, so to speak. So I'm going to draw the axis of symmetry. And when I draw the axis of symmetry, I'm going to do just 1 point here. See how this y-intercepts 1 unit to the left of the x-axis, so that the other points will be 1 unit to the right, like this. And then use this to graph, and there's your graph, something like that. Okay? All right, so we did 4 problems with this. I'm going to try and do a couple more. Doesn't be the next part. So this is about 45 minutes. So notice that there was a lot of discussion with this, but that's basically how you graph quadratic functions when it is written in standard form.